Dear students, good morning. The last class you learned about graphical representation of motion of body. Today class I teach you new part which is equations of motion by graphical method, and you are going to study how to derive equations of motion graphically. What are the equations of motion? Let us consider an object moving along a straight line with uniform acceleration. Can it be possible to relate its velocity, acceleration and distance covered by it in a certain time interval by set of equations? Yes, it is possible. These equations are called equations of motion of bodies. What are they? They are, first equation is V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. Third equation is V square minus U square is equal to 2AS, or 2AS is equal to V square minus U square. Let me introduce these terms. First, U be the initial velocity, V be the final velocity, S be the displacement, A be the acceleration of the body, it is the uniform acceleration, and T be the time taken by the body to cover the distance or displacement S. The first equation represents relation between velocity and time. The second equation represents relation between position and time. And the third equation describes position-time relation, which can be obtained from equations first one and second one by eliminating t. Let me see how to derive velocity-time relation graphically at first. Consider the velocity time graph of a body having initial velocity u, which is subjected to a uniform acceleration a for a time period t. Here, after the time t, the final velocity of the body is v. From this graph, it is seen that initial velocity of the body is u, which is at point capital letter A, and then it increases to V, which is at point capital letter B in time t. The velocity changes at a uniform rate, so the acceleration produced by the body is uniform acceleration. In this figure, the perpendicular lines BC and BE are drawn from the point capital letter B on the time and the velocity axis respectively. Now we need to find the relation between V, U, A and T graphically. From the graph, BC is equal to V, which is final velocity, DC is equal to U, which is initial velocity, which is represented by equation 1. BD is equal to BC minus DC is equal to V minus U, which is the change in velocity in time interval t, represented by equation number 2. We know acceleration A is obtained by the slope of the graph because it is velocity time graph and velocity changes at a uniform rate. So acceleration equal to slope, which is equal to BD divided by AD, represented by equation number 3. We know AD is equal to OC, which is equal to T, where T be the time taken to reach the point capital letter B. Therefore, from the equation 3, BD is equal to AT, which is represented by equation number 4. Substituting the value of V from equation 2 in equation 4, we get AT is equal to V minus U. Rearranging the terms, we get V is equal to U plus AT. Hence, we derived the first equation of motion. In this session, I'm going to talk over the method of deriving position-time relation by graphical method. How to derive position-time relation graphically? Consider the same body having initial velocity u is being subjected to a uniform acceleration a for a time period t. After the time t, the final velocity of the body becomes v. In the time interval t, it covers a distance s. Now we need to derive relation between s, u, a and t graphically. We know that one of the advantage of velocity time graph is that we can determine the distance traveled by a body. Here the body should be uniformly accelerated body. Thus, the distance traveled by the body is obtained by area enclosed by the graph, that is velocity time graph, with respect to time axis or x-axis. As shown in the figure, the distance traveled by the body is equal to area of the trapezium OABC, which is equal to area of the rectangle OADC plus area of the right triangle ABD, since the trapezium is composed of two parts, rectangle and right triangle, which is equal to OA into OC plus 1 by 2 into AD into BD. Substituting the value of OA, BD and OC, we know that OA is equal to U, BD is equal to AT and OC is equal to AD is equal to T. Then we get S is equal to UT plus 1 by 2 into T into AT. So S is equal to UT plus 1 by 2 AT square. Hence we derived the second equation of motion. In this session, let me see how to derive the third equation, which describes position-velocity relation graphically. Once again, we have considered the same body moving under uniform acceleration a along a straight line. From the velocity time graph shown in the figure, the distance s traveled by the body in time t is obtained by the area enclosed by the graph with respect to time axis or x-axis. Here, area is enclosed within the trapezium OABC under the graph. So area of the trapezium OABC is equal to OA plus BC divided by 2 into OC. The distance traveled by the body S is equal to area of the trapezium, which is equal to 1 by 2 into sum of measures of two parallel sides into the perpendicular distance between these two sides of the trapezium. Substituting these values of OA, BC and OC. Here OA is equal to U, BC is equal to V and OC is equal to T, which give rise to S is equal to U plus V divided by 2 into T. From the velocity time relation, V is equal to U plus AT, then AT is equal to V minus U, which gives to T is equal to V minus U divided by A. This is equation number 2. Using these two equations, we get S is equal to V plus U into V minus U divided by 2A. Since a square minus b square is equal to a plus b into a minus b. Using this same mathematical property, we get s is equal to v square minus u square divided by 2a. Then 2as is equal to v square minus u square. Hence, derived the third equation of motion of the body. Let me discuss the numerical part 1 and part 2 will be discussed in next class. Question number 1. A scooter acquires a velocity of 36 km per hour in 10 seconds. Just after the start, calculate the acceleration of the scooter. Here, initial velocity of the scooter u is equal to 0 as the scooter starts its motion at 0 velocity. Final velocity v is equal to 36 km per hour converted into meter per second. How to? You have to multiply 36 by 5 by 18. It will be equal to 10 meter per second. Time given is equal to 10 seconds and calculate acceleration. Here we have to apply first equation of motion. V is equal to u plus at. V is equal to u plus at, the equation number 1. Here 10 is equal to 0 plus a into 10. Then a is equal to 1 meter per second square. The second question is, a moving train is brought to rest within 20 seconds by applying the brakes. Find the initial velocity if retardation due to brakes is 2 meter per second square. Here we have to calculate initial velocity u. Final velocity v is equal to 0 as the train is brought to rest after few seconds by the application of the brakes. Time t is equal to 20 seconds and retardation is equal to minus a is equal to 2 meter per second square. Here retardation be the negative acceleration is equal to 2 meter per second square. Then a is equal to minus 2 meter per second square. By applying the first equation of motion, we get v is equal to u plus at, substituting the values of v, a and t. Then 0 is equal to u plus minus 2 into 20, which is equal to u minus 40. Then u is equal to 40 meter per second. The third question is, a body starts to slide over a horizontal surface with initial velocity of 0.5 meter per second. Due to friction, its velocity decreases at the rate of 0.05 meter per second square. How much time will the body takes to stop? Here, the initial velocity u of the body is equal to 0.5 meter per second. As its velocity decreases at the rate of 0.5 meter per second square, which is understood by the question, the retardation minus a is equal to 0.05 meter per second square. Then a is equal to minus 0.05 meter per second square. Final velocity v is equal to 0 meter per second as the body comes to halt after few seconds. By the first equation of motion, v is equal to u plus at, substituting the values of v, u and a, we get 0 is equal to 0.5 minus 0.05 into t. Then 0.05 t is equal to 0.5. So t is equal to 0.5 divided by 0.05 is equal to 10. Time t is equal to 10 seconds. Next, we are going to the fourth question. The question is, a bike moving with a speed of 10 meter per second is stopped by applying brakes which produce uniform acceleration of minus 0.05 meter per second square. How much distance will it cover before it stops? From this question, it is known that initial velocity u is equal to 10 meter per second. Final velocity v is equal to 0 meter per second. Retardation minus a is equal to 0.05 meter per second square. Here the bike decreases its velocity at a uniform rate, so its acceleration is the negative acceleration, it is the retardation, and we have to find the distance covered by the bike before it stops. So S is the unknown value. By applying the third equation of motion, we get v square minus u square is equal to 2as. Substituting the values of v, u and a. Here 0 square minus 10 square is equal to 2 into minus 0.05 into s, and we get s is equal to 1000 meter. The fifth question is, a train starting from railway station and moving with uniform acceleration attains the speed of 40 km per hour in 10 minutes. Find its acceleration. Here the train starts from rest, so its initial velocity u is equal to 0. Final velocity v is equal to 40 km per hour. Time t is equal to 10 minutes. We have to convert it into hour. That will be equal to 10 by 60 hour. Since 1 hour is equal to 60 minutes, then 1 minute is equal to 1 by 60 hour. Here we have to apply first equation of motion, v is equal to u plus at. Substituting the values of v, u and t, we get 40 is equal to 0 plus a into 10 by 60. Then a is equal to 240 km per hour square. Sixth question is, a train is traveling at a speed of 90 km per hour. Brakes is applied so as to produce a uniform acceleration of 0.5 meter per second square. Find how far the train will go before it is brought to rest. Given that the initial velocity of the train u is equal to 90 km per hour, conveniently we have to convert it into corresponding meter per second. How to? We have to multiply this value by 5 by 18. That will be equal to 90 into 5 by 18 is equal to 25 meter per second. Because the following physical quantity is given in SI unit. So already converted the kilometer per hour into corresponding value in meter per second. Final velocity is equal to 0 because finally the train comes to halt. Here the acceleration is the negative acceleration, which is equal to minus 0.5 meter per second square. We have to find the distance s. Here we have applied the third equation of motion. We get v square is equal to u square plus 2as. Substituting the values of v, u and a, we get 0 is equal to 25 square plus 2 into minus 0.5 into s. Then s is equal to 625 meter. The following are the homework assigned for you. You have to work out today. Thank you.